Despite watching 2 series of The Killing and 1 of Borgen, my Danish still isn't very good. So thank you for listening in English this morning. I used to spend a lot of time here. About 20-25 years ago I worked for Rank Xerox and spent 6 weeks at a time here, but I suspect it's changed rather a lot since my visit. So I don't think I've been here for about 15 years, so it's nice to come back. Jon's explained what I do. Part of my role is to liaise with IBM research. So what you're getting today is a little bit of a view of the future as we see it. So let's start with 2 health warnings. Here's the first. Human beings really aren't very good at telling the future. So whatever you think is going to happen, it's going to be wrong. That doesn't mean that everything I tell you this morning won't happen, but please take it with a pinch of salt. It is very difficult to tell the future. Human beings dramatically over-expect what is going to happen in 1 year and dramatically underestimate what will actually happen in 10 years. And that pattern has been reproduced for the last 100 years, and I see no reason for it to change. So there's a few people who made an awful lot of money by doing things very successfully, but they also got it wrong. Secondly, these are IBM slides, so there's far too much on them. Don't try to read them as we go. You can do that in your own time. So we have a habit of putting too much on there, but there you go. And most of these come with huge speaker notes as well. There's a whole book behind this stuff. Right, Picasso, quite a bright guy, knew what he was doing, made a few bob, painted some nice pictures, but as early as 1968 he recognised that computers had a fundamental limit. They're useless. They can only give you answers. So part of today will be to examine whether that statement is still true. Largely it is, but it might not be for that much longer. So get a little bit worried about what the future of computing might be. And we also live in a very strange world where some people appreciate what's going on and some don't. Digital natives, digital aliens, are you familiar with the term? A digital native is someone who's grown up with technology, who's had a computer in their bedroom since they were about 6 or 7, has had a mobile phone since their parents allowed them to have one, does not understand the concept of a world without the internet. Hands up if you are 24 or younger. At least we have a few. Normally when I lecture I don't have any. Okay. So, if you're 24 or under, you're probably a native. Not necessarily so, because it partly depends on your parents. So you won't use a manual, you won't be able to repair anything, you have the attention span of a gnat, but you can multitask and do things that we of the older generation cannot do. If you are 48 or over, and 48 is the breakpoint age, you run the risk of not understanding how the world works. Now, as you're all here today and all IT orientated, that statement won't apply to any of you. But lots of your peers will struggle with coping with the world and how it works. So have a little bit of pity on them, particularly older parents. And the gap is widening. What's interesting from an IBM perspective is that we're now employing natives. Over Christmas in the UK, there were 2 documentaries, one on Facebook and one on Apple. And if you look at how those companies work in comparison to someone like IBM, then they're streets apart. And that divergence is continuing. We're well aware that we need to actually change things as to how we employ people, and you'll see a little bit more of that later on. But these younger companies are vibrant, very fast-moving, paperless, etc. But it's the attitude of the people that is in them that will make the difference. Okay, we live in a world of largely unstructured data. All right, now that wasn't true 5 or 10 years ago. And in case you were worried about what came after exabytes, it's zeta and yotta. All right, but increasingly we have more and more and more data. And the question is what we're going to do with it. And a large part of this morning is all about data, because you need to make use of it. You need to understand what it is, what the potential is for the use of that data. So this is not a lecture about the next device that's coming down the road. I'll leave that to the Apples and the HTCs and the Samsungs of the world. We don't really do that anymore. Okay. This is really about the impact of data on the world. And give you, I don't know whether you should be able to read that, but that's basically what people spend their time doing. So, 50 million tweets a day, 700 billion minutes on Facebook. All right. Where's it all leading? Obviously, I can't answer that question, or I'd be very rich. All right. But we spend, 2.9 million emails sent every second. That is a phenomenal amount of data. The question is, as I said, what do you do with it? And the key point from an IBM perspective and where we're trying to take things is that by 2015, 80% of all available data will be what we call uncertain. Right? So you've lived in a world of developing IT systems. We started off with paying people's salaries. That was the first application of IT. We have lots of data warehouses. We have financial transactions zinging away around the internet. But by 2015, that will only be 20% of the data that is flowing over the net. The other 80% is all unstructured, so it's blogs, wikis, Facebook, etc. A massive uptake in video, which is already killing the mobile networks, in case you hadn't noticed. That is about to get worse before it gets better. And the anticipated, so there's every minute of the day, there are 24 hours of video uploaded to YouTube. That's a lot of video. What do you do with it? Again, tricky, but I'm going to talk about the Internet of Things as well a little bit later on. But you can see that traditional data down the bottom here, that really isn't much of what is going to be around in the world in years to come. So, how are we going to deal with that? I'll try and explain some of that. Sorry about the quality of this one. I ripped this one off Wikipedia, so it's not very good. Data on its own means nothing. Give it a bit of structure, it becomes information. Right? From information comes knowledge. From knowledge comes understanding, and eventually from understanding comes wisdom. But to go along that path using IT systems and our own brains, that's actually quite difficult. Right? And most of the time, we're stuck over here. So the question is, how do you get to there and add value to enterprises and your own personal lives? Again, it's not an easy thing to solve. And not part of this talk, but one slide, it is vitally important to understand how the money flows with regard to the internet. Who is making money out of the net? How do the tier 1, tier 2, tier 3 providers link together? How does the money flow? Because ultimately, to stay in business, you need to understand how the flow of money works on the internet, how people cut out some of the tier 1s, how they do private deals, etc. It's an hour's lecture in itself, right? But it is so important, right? And one of the things that we spend quite a lot of time doing is looking at the mechanics of the money flow on the net. So I'll leave that one there for your own personal investigation, but don't ignore it, because companies succeed or fail depending on the relationship with the providers on the net. Talk a little bit about IBM. We celebrated our 100th anniversary last year on June the 15th. It may have passed you by. You didn't send us a card. We're not upset. These are some of the things that we have done over the last 100 years. We register more patents every year than any company in the world, and we've done that for about the last 40 years now. And that includes Google, Apple, and everybody else. Every time you buy something in a shop, the barcode was invented by IBM. Every time you withdraw money from an ATM, you are using our technology. We put Armstrong on the moon, etc. Right? The important thing here, and we're going to talk about innovation for a moment or two, there are two types of innovation. There are disruptive innovation and continuous innovation. So when we moved from the manual typewriter to the electric typewriter, that is continuous innovation. It made life easy, but it really didn't change the way the world worked. When we moved from the electric typewriter to word processing, that is disruptive innovation. And that is the key to moving the human race forward, is the ability to have disruptive innovation. It's what we look for when we're trying to recruit the best of the best into research and so on. So really very, very important. And it might seem strange from an IBM person, I'm now going to show you an Apple advert, right? To ram that point home. So in 1997, IBM had a motto called Think, and Steve Jobs at Apple decided that he wanted to contend with that, so he came up with Think Different. Right? The ad that was released, which is about 1 minute long, was originally voiced over by Richard Dreyfuss, the American actor, but when Jobs died last year, they re-released it with Jobs' voiceover, and you can find this on YouTube. It's easy to find. So please listen to the message in the ad, but also, for a bit of fun, there are 17 phenomenally famous people in the ad. See how many of the 17 you can get.
Here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes, the ones who see things differently. They're not fond of rules, and they have no respect for the status quo. You can quote them, disagree with them, glorify or vilify them. About the only thing you can't do is ignore them, because they change things. They push the human race forward. While some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.
Quite powerful in what it says. So we are constantly looking for people that can do that sort of thing. How many of the 17 do you get? Largely US and UK centric, I guess, but Gandhi's probably not very UK. Okay. I'll run it again later if anyone wants to test themselves. One of the points about all of this and the rate of change is that nobody has the right to succeed and to stay in business. Right? The first book on business strategy ever written wasn't published till 1960. So until then, you just did what your father had done or your predecessors had done, and you made a lot of money and you went home, and technology wasn't there to assist you, and things worked very, very slowly. And then the rate of change started to happen. And Alan Turing, who was the father of modern computing, who worked at Bletchley Park during the war, deciphering Enigma signals, started the world on a road to what we have today. Meanwhile, IBM had come from being a manufacturer of time recording equipment, which is what we started doing, to the makers of computers, the IBM 360, if you remember that. It's the most successful computer of all time. And in 1984, we were one of America's most admired corporations. Sadly, by 1992, we were a dinosaur. So we had a compelling reason to change, because otherwise, actually, we weren't going to survive. So while Jobs was digging Apple out of being 6 weeks away from bankruptcy, Gerstner was doing the same for IBM. It may not be that well known, but we were 8 weeks from bankruptcy. And basically, the company was reinvented and restructured. It was very, very close as to whether IBM went under. When Gerstner came in, IBM had 150 CIOs in Europe. When he finished, we had one. Right? There were lots of fiefdoms, lots of individual empires, and the company really had missed the PC. So we might formally be recognised for inventing the PC in terms of history, because that date in August 91, when IBM created its PC, is recognised in the industry, but actually we missed the whole thing and we didn't make a great deal of money out of it. So Gerstner came in and fundamentally restructured the company. And even if you go back as far as 2000, we were still making reasonable money from hardware, a lot from consultancy and not that much from software. But the hardware market is a commodity market, certainly at the bottom end. And you may have noticed we don't do IBM PCs anymore. We don't do any small devices at all because we can't make money at it. We sold it to Lenovo in China, and they do make money at it because, of course, they're dealing with massive volume and have got the right infrastructure and social infrastructure to actually make money out of doing it. But we couldn't make money out of it. So we got out of that market. We got into software and more services and consultancy. And as you can see, 84% of IBM's revenue today comes from services and software. 9% comes out of financing our own deals because we're one of the most cash-rich companies in the world. And 7% only comes out of hardware. So we don't really do it anymore except the really big stuff. Okay. And that trend will continue, there is no doubt. One of the reasons I work in Software Group is it's a nice place to be because we are a very large and growing business. And we have acquired hundreds of companies in the last 5 to 10 years, and we will acquire them at the rate of 15 to 20, maybe even 25 a year, that fit in with IBM's strategy, which I will shortly come to. And we've also changed from being a horribly US-centric organisation where the power was concentrated in Armonk to allowing the various companies around the world to operate largely autonomously. In a world where we're not recruiting many people, we recruited 70,000 people last year, all in China, right, and India, right. So a huge amount of our revenue comes out of what we call GMU, or the emerging markets. That is true not only of IBM, but lots of other corporations as well. IBM would probably like it if I moved to China or Turkey or India for a couple of years. They want their resources in that part of the world. Actually, we've got too many in this part of the world, but there you go. We can't, not everyone is going to up sticks and move to the Far East. So constantly changing, constantly trying to keep up with the pace of technology change. And just to reinforce the point, if you look at the top 500 companies from 1975 in the index, there's only 75 of those left. 425 don't exist anymore. They've been acquired, deleted, taken over. So no one has the right to survive just because you used to be good. So innovation and change, both at an individual and a company level, is really about where we're going in the future. Okay, so that's the context. So GTO stands for Global Technology Outlook. How does IBM decide what it is going to do and what it is going to invest in? So the GTO identifies significant technology trends early. It looks for high impact if disruptive, remember that from earlier, to game-changing products and services over a 3 to 10 year horizon. We are trying, despite what I said in the first slide, to actually foretell what is going to happen in the future. So technology thresholds and demonstrate their influence in clients, enterprises and industry. We want things that are going to make a difference, both to ourselves in terms of how we evolve and how clients and society will evolve. The GTO is a living being. It's produced every year by IBM Research. Every December, it's presented to the IBM board in a 2-day away session somewhere in the US. We had a new CEO, our first lady CEO in January this year, Ginny Rometty, who replaced Sam Parmesan, and they were both part of December's meeting. The board reviews the GTO and then makes adjustments to IBM's overall strategy on a worldwide basis based on what it is seeing from the GTO. And again, sometimes we get it wrong, and sometimes we get it right. Some themes only last a year in the GTO, but quite often they last 3, 4, 5 years as they evolve and develop over time. And I'm going to take you through some of that in a moment. But basically it's there to govern our strategy. It's probably the most important piece of work that we do. What you are going to get is a 50,000-foot view of that this morning to support what I'm showing you. On each topic there is a 1-hour video, and behind that video is something like a 100-page book giving all the detail. Yeah. So I'm looking at the last 2 years, and what we do is we break this into areas. So from an IBM perspective, last year our key themes were the Smarter Planet. Please tell me you've seen at least one Smarter Planet advert. Yeah? Hands up, one. Yeah, yes. See, we have reached. Yeah, that's good. Analytics, which is probably the core of what's going on. Don't need to worry too much about these two. And then there are themes, and last year there were 5 themes, and I'm going to do about 3 of those. And then we come on to this year. We've sort of made it a little simpler this year, so we're going to talk about managing uncertain data at scale and the future of analytics. So analytics is going to be there for the next 10 years, basically. I see very little danger of it falling off the chart because it is all about data. We'll talk about systems of people, the future of Watson. So I got the Watson bit in the Danish earlier, but I'm not sure what John said over and above that, but I will talk about Watson. Outcome-based business. The last 2 I am not going to do. They're rather dull in comparison to the others. So just a little bit, 2 more bits of context here, I think. The evolution of thinking machines. Anyone got an abacus at home? No, good. Splendid, we've moved on. All right, so here you go, very, very slow development, and then into Bletchley and ENIAC, then System 360, Deep Blue, Watson, and we're going to talk about the concept of learning systems. Notice here, within 10 years a digital computer will be the world chess champion. That was said in 1958. Well, 10 wasn't a bad estimate, but 39 was actually the figure. So yet again, human beings not quite good enough to do the prediction for the future. So this is the only technology bit. This is processing power of computers. Where basically, this is brain operations per second, for want of a better word. And you can see it's linear. Starting back in 95. We actually reach a crossover point next year when computers are capable of the same number of brain operations per second as the human beings that you and I represent. So finally computers have caught up with man. Are they capable of creative and cognitive thought? We'll come back to that one a little bit later on. But as we'll see in a minute, that line is not going to stop. At least not for the next 10 years. Right, so there are some implications here. Deep Blue down here, which is the thing that beat Kasparov. If you brought Deep Blue in here, it would probably take up the first 3 rows of this lecture hall. Right? Today, that is represented by the chip in an Xbox. So things have got a little bit smaller. Why is there a lizard on the chart? Okay. It has taken man 40 million years to evolve from being a lizard in terms of brain power to what you and I represent today. It's taken computers precisely 40 years to make that same journey. So, where's the future lie? So by 2018, the computer will be built that exceeds the computation of the human brain, and by 2023 it will only take $1,000 to exceed the capabilities of the human brain. By 2049, a $1,000 computer will exceed the computational capabilities of the human race. That really is quite scary, and obviously those predictions are wrong. It will happen quicker. Computer power in 1969. So we put Armstrong on the moon. The only question I ask is how the hell do we get him there and get him back, given what we were actually using to do that. If you look at an iPhone, it has 1,000,000 times more memory, is 1,000 times faster, 250 times lighter, and 360 times smaller than the computing engines that we used to put Armstrong on the moon. It's stunning to think that a little device of like an iPhone, whatever, I've got one somewhere, this is greater than the computational capability of the 3 rooms of kit we had at Houston. Sadly, of course, human beings aren't getting any quicker. All right? So while computers improve, we don't. So on average, you will read 450 words a minute when you read a book. If you're really, really bright and very quick, you'll do about 800 words, but that's about the maximum for the human race. But we're churning out all this data. So how do we absorb that? How do we use it? Because you can't read it any quicker. You're not going to change. We're developing HD TV sets, HHD TV, whatever's coming next. What's the limiting factor? These things. They're not getting any better. At a point in time, and we've reached it in one of the labs in Zurich, we can create a better display, but we can't tell that we've created a better display because we can't actually see it any better than we could see the previous version. So where does that stop? That's just another question. Moore's law, I think most people know Moore's law in the IT industry, and the reason that computers will continue to develop is that basically Moore's law will hold true. Some people say 2018, some say 2023. We are doing a lot of work in the labs to look at what comes after silicon. And that's some of the more secret research, but we're not the only company doing it. Intel are doing it. No doubt Google are looking at it, HP, etc. So man tends to always come up with an answer, so let's assume that something will follow on from silicon. There are only 7 atoms between some of the transistors at the moment, so there must be some limitation in there. And also you're going to get a thermonuclear reaction in your lap unless we do something about heat dissipation. But that's another problem for another day. What we're basically saying in IBM is we're really entering a new Moore's law for the 21st century. So software plus the existing Moore's law plus wireless plus miniaturization and nanotechnology takes us somewhere we haven't been as a race before. So you're basically at the dawn of the instrumentation of the world. But what you are about to see, and I'll talk about the Internet of Things in the next slide, is vast amounts of data sent by machines somewhere. And automatic sensor-based information acquisition. So no human interference, just a huge change in the rate of the creation of data by automated devices. So the Internet of Things is a foundational infrastructure for the smarter planet, growth opportunity from our perspective in infrastructure and services. So today there are 7 billion devices connected to the Internet, 1 for every human being on the planet. By 2020, you are going to 50 billion at conservative estimates, all sending information about something. Right. Data is only any good if you can do something with it. To reinforce a point I've probably made 3 times already. You need an infrastructure to manage that. So what are you going to do? So lots of talk of near-field communications, money transfer, etc. via mobile phones, mobile wallets, right? Congestion charging, all sorts of things, right? But you can put a chip in anything. You chip your dogs and your cats already. You're probably going to chip your children at some point, maybe. We've got several unpublished cases of children in the US recovered from kidnap situations because the child is chipped. Right? These things happen. Right? If you watch 24 TV series from the US, some of the stuff in there is not too far short of the truth. And certainly talking to some of the government agencies in the UK, there's some phenomenal stuff coming. And what the government agencies don't know about you, you really don't want to know anyway. So, we have got to create an infrastructure to cope with the Internet of Things. And that is what we're trying to do. And it's what we call big data. And one of the fundamental differences at this is historically data is at rest, but we're now talking about data on the move. So cars, trains, planes, whatever. Right? As I said, if you put a chip in something that moves, you've got to be able to track it, you've got to be able to take the information. Right? So the day of the traditional data warehouse and business intelligence is not ending, but it is only now part of the story. So this is some of the stuff that we've got going on. Homeland security, 500 billion, 50 billion records a day. Again, a lot of information, and we are trying to make the best of doing something with it. So big data is a term you will already have heard, or you will be hearing a lot more of. Just a little bit of word of warning about data and clouds, because everyone assumes that cloud is the answer to everything. There's a fundamental problem with cloud mechanics, and that is the cost of moving the data. So typically, the CPU for processing it is very cheap. Storage is very cheap. Moving it from A to B to do the storage and the analysis is very expensive in comparison. Therefore, you will find cloud solutions actually move to the edge of the network to be close to where the data is acquired. So I work in telecommunications, so you will see processing solutions in base stations rather than using the data to move from the base station to a central repository to be processed and that move back again. It's too expensive. So the cost mechanics for some of the cloud solutions that people are currently proposing are invalid in our opinion, and we are looking at that. And IBM presented at World Mobile Congress this year on solutions around bringing that data closer to home. So, dedicated systems are not dead. Clouds are not the only solution to large data processing. Managing uncertain data at scale, so we've more or less had that one already. So for each topic there's a summary slide, and this is a summary slide for uncertain data. Basically we've got a fourth, so we've already had volume and velocity and variety, so do everything with a V. But we've now got veracity. So when you've got uncertain data, how true is it? How accurate is that data? Because depending upon the accuracy of the data will depend upon the analysis that you can perform upon it. So we've got the traditional, but we're now entering a world of data in doubt. Unlike transaction systems, you cannot guarantee the quality of the data. So as an example, GPS data. So you take a bit of GPS data from 3 lorries and you discover they're in the East River in New York. Well, they're not, obviously. They're on the road next to the East River in New York, but the data, the GPS is not accurate enough to give you a 100% accurate record. Therefore, you have to do some interpretation. So that's a very simple example of data that is at doubt, right? And again, when you start to model data, and all modeling is approximate, right? It's not an exact science. So we have to come up with stuff to change how we model data. The traditional one, John Smith of Dallas, John Smith of Kansas, is it the same person? Historically, computer records for companies have 27 versions of the same person with slightly different spellings. So that's, again, uncertain data. We need to get a lot better at how we interpret the data. this is basically saying that data is probably the most powerful thing that companies own. It's why you get massively high valuations on Google, Amazon, and Facebook. And increasingly, those companies that own data and can do something with it are going to be the companies that succeed. So owning data is not enough. Google, obviously, with its ad model, has turned data into money. So how does YouTube do that? Not sure yet. Facebook's sort of moving towards some sort of successful business model, but it's not really there yet. But we're only at the birth of social networking, so that's okay. These companies will make money eventually. But all of these other industries need to think about how they make money out of data, because on that they will sink or swim, survive or die. And again, statistical techniques. So there's a lot of work going on mathematically to create the next generation of analytics, and I'll come back to that. Trouble ticket is a good example in the telecoms industry. You get a trouble ticket from someone saying, I've got a fault. If you've got all the data from the 100 faults like that previously, then you solve the problem a lot more quickly. But that requires accurate models, the ability to strip out irrelevant data and concentrate only on what is important. And there's a quick summary of technical challenges in uncertainty reduction. So all those people who made a lot of money around things like master data management, data warehouses, they're still going to make a lot of money for the next few years, but they're going to have to change what they do. So the future of analytics, huge opportunities now then to do something with the data, reduce cost of value. Analytics becomes a dominant IT workload and drives hardware design as well, and I'll come back to that one in just a moment. But it's really all about volumes of data. So analytics is broadly defined as the use of data to computation to make smart decisions. The ability to take information, translate it into something that is worth something to somebody. Typically at the moment people are worried, how do you take all the information you've got about your customers to be able to upsell, cross-sell, solve problems easily, create good relationships, right? So I work in the telecommunications industry. These guys have got 20 years of data that they've done nothing with because they spent the last 20 years trying to stay ahead of the game technologically, and they haven't had time to investigate the data. Now they're being killed by Google and Amazon and all the over-the-top providers, and their business models are shot to pieces. So unless those telecommunications company makes some use of the data in the next 2 or 3 years, they will end up becoming dumb pipes, just providing network connectivity, and they will have a vastly different business model. So they're right on the cusp now of failing, and we're beginning to see some of them change their strategy because they realise they can't be in that game. So that's a lecture for another day again, but that is the type of thing that is happening. And this is probably one of the key slides in this deck. So there's a whole load of stuff. The grey stuff is what we do at the moment. That's what IBM has bought and acquired, companies to do all this stuff. What we're saying is we're going to introduce new methods of analysing data, and actually the data itself is going to change. The data is richer, there is more of it. So these are the traditional things that we do, but the learn and collect, ingest and interpret are part of what we are going to do. And Watson, which we'll come on to, is an engine, a computing engine that enables us to do some of that. So solution development requires several interacting design steps. Again, I'm not going to go into this, it's one of these slides with too much information on, but you need kit. Not only do you need a method, but you need an engine, and we'll come back to that one as well. So an analytics solution platform. What is going to happen is that instead of having software and hardware sold separately, we're going to end up with what IBM calls an appliance. The hardware and the software get sold together. We don't have time to actually put everything together in a jigsaw. People want plug-and-play solutions. So you're going to get far more, and not only from IBM, but other companies as well. They'll sell you the hardware and the software as a total solution, be it analytics or anything else. And in about 3 weeks' time, IBM is going to make some fairly significant announcements around an entirely new platform to do precisely this. So the CIO can reduce cost, add value, and time to market because he'll be able to buy an out-of-the-box solution for some of the complex problems that the world faces at the moment, or companies face at the moment. So as it says here, revenue, so we drop the lines of code because it's pre-delivered, we increase the revenue, we increase the speed to market, and hopefully everybody's happy. It's basically the same. I'll skip that one. It's basically saying the same thing. If you optimize across the whole stack of everything you do, hardware, software, services, get it all in together in a single solution, people are going to be a lot happier in terms of time to market, etc. Socially synergistic enterprise solutions. What a mouthful. We're basically talking about people. So what you're seeing is the convergence of social and analytic technologies. So business process transformation has always been the way of optimizing how businesses work. What we're beginning to realize is that people are rather more important than the process, and we need to concentrate far more on the people and what they are capable of doing and getting the best out of the people as well as the technology. So is there anybody in the room who's not a Facebook user? Raise your hand. 2. Excellent. All right, that's about average. Okay. Anyone who is not a LinkedIn user, raise your hand. A few more. Okay. But increasingly, we communicate through social networking tools, and we need to understand those. Companies need to understand how to optimize those and to optimize the resources that are contained within its HR community, i.e. the people that it employs. Metcalfe's law states that the value of a telecommunications network is proportional to the square of the number of users connected to the system. Same is true of social networks. So the more people you have, the more people that are connected together, the more powerful that solution becomes. Yeah? So you're all used to Facebook. For your parents, here's Pension Book, a moment of light relief. So take pity on your parents. Right, that was my water stop. There are problems with social networks. As I said at the start, you're only at the start of social networks. Dunbar's number. Anybody come across Dunbar's number? Basically, human beings can only react with a certain number of people in an unstructured environment. So your ability, you will not have more than 150 close friends, and I doubt whether most of you have got 150 close friends. If you look at your Christmas card list, so I don't know what the sort of social norm is in Scandinavia for writing Christmas cards, very few people have a Christmas card list that's greater than 120, right? Unless you're a business. Right? You are incapable of reacting with more than 150 people, and most people don't get to that. Yet Facebook, people have hundreds and thousands of friends. Right? So you reach the point where Facebook, you're a little bit concerned about how it works and how much information you release. Right? So one of the proposed successful companies in the UK and probably Western Europe for 2012 is a company called Path, which is a new social network which basically limits you to precisely 50 people in terms of how many people you interact with. People feel a lot more comfortable with 50 than they do with 250 or 350. So you become much more intimate, more personal. The revenue model is unclear, right? And it is only now launching. But maybe that is the next thing that follows on from Facebook, because Facebook is not the end of this by any means. Yeah. So what's next? Path is one possible example of what is next. But remember Dunbar's number, it's true of apes as well, by the way, or any primate. So we took the idea of social networks and basically then started talking about systems of people. So this is 2012 version of the people thing. So organisations have extracted efficiencies from traditional process automation. You could debate that. There's a long way to go for most organisations. But we need to make use of social business, an opportunity to instrument people and processes. The opportunity to drive business value from IT is shifting from process to people-centric. So we've got a lot of people in most of these areas who know an awful lot about customer and the company. At the moment, we don't optimize the use of those people. What we are looking to is to develop systems that do precisely that. It's not the same as optimizing supply chains, because you're talking about unstructured data again. People know stuff, but it's not written down. So how do you get the best out of people? So it's starting to throw through online collaboration and systems internally, but you can only do something with analytics if you can capture that information. So we're at the start of this journey. I'm not going to tell you that we've got new solutions rolling off the block, but we will be acquiring companies this year to help us move towards utilising people much more efficiently in large enterprises and small enterprises. So it can differentiate, grow emerging markets, transform, and you can read it yourself. We've got to make companies more efficient because certainly in the Western world, the cost of employing people is quite expensive in comparison to what's happening in emerging markets, and we don't want to lose any more of our business to emerging markets and suffer recession again in Western Europe. So if we're going to be good, we've got to get people to work well. And we're talking about people, so new data set about people, new way of using analytics to analyse what people do, and a new way of enabling global workforces. IBM collaborates across the world. We have 470,000 employees, but we have collaboration systems that are available to all 470,000 people. Right? We have one of the most powerful networks in the world, admittedly, but to survive as a global enterprise, you have to collaborate and you have to optimize across international boundaries, and that is a non-trivial exercise. And rich and reliable people content will be the critical capability behind systems of people. And again, lots of data on the slides, but it's all about getting the data, being able to analyze it, and making sure that you've got all the data that you need. So the word data I must have used about 1,000 times so far this morning. That's the people side. Now let's come to the technical side. So frontiers of IT. New class of learning systems. So computers, when we did Deep Blue, it did number crunching. It's what's called tree search. It's brute force to solve the problem that was chess. Right? We then moved on to techniques such as neural networks. So again, going back into the games playing world, not many people know that an IBM professor in the US created the first neural network program that successfully created a backgammon program that could play at world-class level. Right? So number crunching, neural networks. We're now talking about a world of autonomic computers and learning systems. So computers that are capable of developing themselves without human interaction. Right? Because human beings just aren't quick enough. I'm not going to go to this in too much depth, A, because of time, and B, because of the complexity. You have to read around this stuff. And what we're basically saying is that today, if you've got general purpose systems with a bit of software, it's very difficult to differentiate. Yeah? What you want is a computer that can learn from its past experiences and bring that experience to bear in solving the next problem. It also requires computers that can analyze and pull together millions of threads of unstructured data. And to be able to do that, you need a very different processing engine in terms of what it is capable of producing. But that will create differentiation. And this is the structure of a learning paradigm. So, again, each of these takes time to talk about. There are engines within the computer for training and learning. There are engines that create hypotheses, but it's the computer that's creating the hypotheses, not the human beings. So the human beings give the capability to the computer, but the computer creates its own hypotheses, tests them, and rejects them or accepts them. So that's a step forward in how we compute. And again, the verification engine, it's a bit like neural networks plus. Neural networks, you give something a base set of rules, and then the computer works out what's best. And this is sort of like that on steroids, if you like. So the computer begins to teach itself what is good and what is bad. And historically, it only acted on structured data. We're now acting on unstructured data. So the classic example that I would give is if in 2001 Watson had existed and the federal agencies had fed all the data that they had into Watson, 9/11 would never have happened because it would have been picked up very, very early by an engine like Watson. It would have drawn the threads together and said, hey, there's 10 guys down in Texas who are learning to fly but don't want to land a plane, plus various other pieces of information. And in all likelihood, it would have been stopped. No guarantees, but that is the type of thinking that we're talking about. So the first incarnation of these is a thing called Watson. That's not named after Watson as in Watson and Holmes. It's named after Watson, the founder, previous CEO of IBM. And to test it, we created it. We spent $6 billion to win a game show. Now, that's maybe a little bit over the top, but obviously there are things to come. So Jeopardy, anyone familiar? I saw some hands go up earlier. Who's familiar with Jeopardy? Hands? Okay, so they give you the answer. You have to work out what the question is basically the concept of Jeopardy. This is a little video about Watson, what it is, how it won the game, and what happens next.
And you're in third place. That means you go first in Double Jeopardy.
The Double Jeopardy round of the first game I thought was phenomenal.
Watson on a tear. Watson.
Who is Franz Liszt?
You are right.
What is Ireland?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right. And with that, you move to $36,681. Welcome to the deciding game in the IBM Challenge here on Jeopardy. The second game was a whole other story.
We struggled some at the beginning.
Actress who direct for 1,000.
A Bronx Tale. Wrecked.
Who is Robert De Niro?
Wrecked.
That was an awful category because Watson got every single one right, but was just a little too slow.
Penn was doing very well, and the risk was, Ken gets a daily double, that's big, gets it right, he's going to be well ahead, and then with that kind of lead going to Final Jeopardy, if he bets enough, he can win in the match.
A camel is a horse designed by this.
So could you wrap it in 5 minutes?
Familiar settings for 2,000. We gotta find that last daily double. We gotta find that last daily double.
I was nailed by it. I mean, it was just intense because these guys were good.
Ken.
Where's the brain?
Brain, yes.
It was a crucial moment in the game. There was still a daily double on the board, and it was starting to become pretty clear that it was in the legalese category.
Let's go to legalese for 1,200.
This person is appointed by a testator to carry out the directions and requests in his will. Watson.
What is executor?
Right.
Same category, 1,600.
Answer. There you go.
That was the moment when I knew it's over.
Our three players have made their wagers. The category is 19th century novelists, and here is the clue. William Wilkinson's An Account of the Principalities of Wallachia and Moldavia inspired this author's most famous novel.
What Watson wants to do then is preserve the lead, not take a big risk. especially with Final Jeopardy, because just like for humans, Final Jeopardy is hard for Watson.
Like, we knew we probably were gonna win, but what if we didn't turn on the system to play in tournament mode? What if we did the math wrong for some reason and lost by $1 instead of won by $1?
I wanted to wait till we see the final scores there because you don't know if something might surprise you.
You came up with what? Who is Bram Stoker? You are correct. Over to Ken Jennings now, and we find who is Stoker. I, for one, welcome our new computer. Now we come to Watson, who is Bram Stoker, and the wager. Hello, 17,973, and a two-day total of 77,147.
It's still sinking in for me. There's definitely a huge sense of pride in Watson, but I think what that really means is pride in the team that built him.
They're very justifiably proud of what they've done. I would have thought that technology like this was years away, but it's here now. I have the bruised ego to prove it.
My past Jeopardy experiences have been great, but we weren't really weighted with this kind of technological, philosophical importance. I think we saw something important today.
When I do step back, I think it really is a very important technical achievement that will reveal both really important applications, but it also reveal a deeper understanding of our own intelligence, which is fascinating.
Think about the internet. No one knew what the internet was going to become and how much it would become part of all of our lives and how useful it would be. When we have questions, that's where we go now. Something like Watson has that same promise. It's transformative in the sense that you don't even know yet what it's going to become.
Of course, this whole project is not ultimately about playing Jeopardy. It's about doing research and deep analytics and a natural language understanding. This is about taking the technology and applying it to solve problems people really care about. We're just so excited about all the things we can do with this.
I had thought this is the end. We'll get there, we're done. And I'm realizing it's just the beginning.
So hopefully that gives you some idea. I'm going to race through the next couple of slides because of time. But Watson, we're going to extend Watson. So it's great to win a game show. What are we doing now? We're going to apply it to each industry. We're already using it. So what we want is a deeper understanding. So we can take shallow understanding, low precision, deep understanding, but brittle, high precision, put the two together and get deep understanding, high precision. Which is basically what we're trying to do. I'll skip that one. But basically, we're using it now for medical diagnostics. So Watson is already solving people's medical problems more accurately than doctors because it looks at the symptoms, then it goes and finds out what information it needs to make a better diagnosis, gets the questions asked, gets the answers input. So at a very simple level, that's a very simple example. But it is saving people's lives already in terms of what it can do. And we're going to take that and apply it to each industry in terms of the analytics that it can perform. That's not cheap, so you won't see this happening overnight. But increasingly, that type of technology will become the dominant way that we look and use computers to solve analytics problems. So 2 more slides. Where will it all end? So you've seen the rate of progress of computers and the fact that man is lagging behind slightly. This is a 1949 mock-up of what a PC might look like. One man in 1968 worked out what the answer was. So if you ever want to know where the world is going and what will happen, read the best short story ever written by the science fiction writer Isaac Asimov. It has, in my opinion, the best punchline of any story ever told. And it was his own favourite story. You can find it on the net, obviously. And finally, from a games playing colleague of mine, the quote, "A good question lights 1,000 fires, a good answer merely permits savages to sleep." We constantly look for the people who can ask the questions. The computers, and lots of us can do the answers, but we really want the people who can ask the questions. And on that, Any questions?